So let us reflect a bit on color. Yes, it was a little bit of a pun, but color is our perception of the combination of wavelengths of light. As we learned, different wavelengths of light correspond to different colors, and at least if it's in the visible spectrum, that's true, at least for human beings. Our perception of color, wavelengths from about 400 to 750 nanometers or so. And we have what's called the primary colors. Those are red, blue, and green. And when we add these wavelengths together, that gives us white, because effectively it's like adding all the wavelengths of light together, which gives us the perception of white. So we're combining all the different wavelengths. And you've probably heard that before. Those are the primary colors, like RGB for a computer screen. Yep, different pixels with different intensities to get the various hues that we want. All right. Secondary colors also, then, red and blue. Red and blue, you combine them together and it produces magenta. Blue combined with green gives you the secondary color of cyan. And red and green combine together to give you guessed it, yellow. You've probably all seen this color wheel or something like this. So here we have red, blue, and green, primary colors. And so red and blue are making magenta, blue and green making cyan, and red and green make yellow. All right, now let's also consider the complementary colors. So the complementary colors consists of a primary and a secondary. And they produce, well, let's see, primary and a secondary. Well, without trying to go through the logic, let me just give you the answer. It's white. And you can see that as follows. You take red. Now, that's a primary. Now, the other two, blue and green, make a secondary. Blue and green make the secondary cyan. So if you take red and add it to cyan to it, it's kind of like you're adding all the three colors together and you get white. So with that same logic, blue and, well, let's see, red and green, so add yellow to it. And finally, green and red and blue make magenta, so add magenta to it, and you will have white. Isn't that cool? But wait a minute, Mr. B. My art teacher in 3rd grade or 6th grade or whatever it was told me that the primaries are red, blue, and yellow. So what gives with that? Are you lying to me? Is this a little bit of deception here? Well, hold on, my dear little apprentice. Hold on. You need to understand the physics, grasshopper. And it turns out to be as follows. The misinterpretation is because of the following. So when we have an object, here's an object sitting before you, not light shining in your eye, but an object of a certain color, it's because it's reflecting the wavelengths of light corresponding to that color. If you see a red rose, guess what? You are not being presented with blue wavelengths. You're presented with red wavelengths of light. That's why it looks red. The other wavelengths in the visible spectrum are absorbed. So this is different than adding wavelengths of light. This is now basically subtracting all the colors, but the one that's not being absorbed, so it's being reflected. And that's the color that you see. So let's consider the subtractive process. So in the subtractive process, we are not adding wavelengths of light, we're taking them away from white. You start with all the wavelengths and you start removing some. So the primary pigments are absorbing one primary color. but reflect in the other two. The primary colors are red, green, and blue. All right, so two of them are being reflected. One is being absorbed. So we're absorbing the different wavelengths. What's going on here? So if red is absorbed, the other two are reflected, and the pigment is cyan. If blue is absorbed, the other two are reflected, and that pigment is yellow. If green is absorbed, the other two are reflected, and that pigment would be magenta. So the primary pigments all combine together to, well, subtract all the colors, and you get black. So all the wavelengths are absorbed. So here's our little subtractive wheel. There's all three pigments making black. But you can see that if red is absorbed, there's red, then the other two are blue and green. Well, blue and green is cyan. All right, so there it is. If blue is absorbed, then the other two are reflected. Red and green are reflected, which comes from yellow. And if green is absorbed, the other two are reflected, blue and red, which is magenta. Okay, so I don't know, I find that a little confusing actually, but that's how it is. So the secondary pigments, they absorb two primary colors instead of one and reflect one primary color. So green and blue being absorbed, the pigment is red. Red is the one that's left. If green and red are absorbed, green and red, then the pigment is, that's right, blue. And if red and blue are absorbed, then the pigment is green. So those are the secondary pigments, absorbing two, reflecting one. The primary light colors are the secondary pigment colors. Look at that, the primary light colors, red, blue, and green, are the secondary pigment colors. And the primary pigment colors are the secondary light colors. Are you confused yet? Well, if not, then you've got a really logical, clear mind. Okay? And then finally, the complementary pigments. Complementary pigments, we take one primary, one secondary pigment, so a primary pigment and a secondary pigment, to produce black. All right, so yellow and blue. So yellow has red and green, okay, and then blue is the third one. Cyan, which is green and blue, and red. And finally, magenta, which is blue and red, and green. So when you combine those together, you've again eliminated all the wavelengths. So that's, in a nutshell, the subtractive process, and it can be kind of difficult to keep all that straight, but at least it gives you an idea about the difference between subtraction and additive. Probably in our technological age, we're more commonly using the additive process, especially when we say something like RGB and we're looking at the response of a screen on your smartphone or anything else. They are the result of wavelength combinations and the emissions that they produce from that. But nevertheless, there is some information on color, and may you have a very colorful day.